Hello, Chem 1A. This is Chapter 6, Lecture Video 2, and we're going to be talking about heat transfer in this video. So, how is heat transferred? Energy is always going to transfer spontaneously from an object at higher temperature to an object at lower temperature. For instance, if a warm-blooded mammal, right, grab a cube of ice, my body is going to be at a higher temperature than the ice, and so heat will flow from my hand to the ice cube. And this will feel cold to me because my hand is losing energy. Heat is leaving my hand, and that's why my hand feels cold. An object whose temperature increases is therefore gaining the energy. So in the ice cube analogy, right, the ice cube's temperature is increasing because my body is heating it up, right? And my body is going to get colder. My hand is going to get colder at least, and it's going to lose thermal energy because of that. So the ice cube's gaining the thermal energy. My hand is losing the thermal energy. This energy transfer, well, not in this analogy because my body is regulating the temperature of itself, hence warm-blooded. But let's say we put that ice cube in some hot water. The ice cube will again gain energy from the hot water. The water will lose energy to the ice cube, and this will continue to happen until both the ice cube and the water are at the same temperature, or more likely the ice cube is melted and the cold water that made up the ice cube is now heated up to the same temperature as the warm water. So this is kind of how our temperature thing works here, just kind of give you an idea. If I heat up this chunk of metal to a really high temperature using that Bunsen burner, and I put it into this water that's at 20 degrees or 20.7 degrees Celsius, the metal is going to lose energy to the water, right? Because the water is at a lower temperature, and the water is going to gain thermal energy. Eventually, these two will, if we leave them around long enough, reach the same temperature. And as you can see here, the water's temperature ends at 36.2 degrees Celsius. That's what the metal's temperature would be once we hit what's known as thermal equilibrium. Thermal equilibrium is a state when we've come to the same temperature and no more energy is being transferred in or out of the two substances. So all of this works in that same idea that we talked about at the end of the last lecture video between system and surroundings. All right, so energy is always going to be transferred in or out of the system, right? So if energy is going from the surroundings, right? So let's say it's going from the surroundings into the system. A couple things happen. We say the system is gaining thermal energy, or in other words, is gaining heat. Q is often used as a symbol for heat, lowercase q. So if energy is moving from the surroundings to the system is gaining heat, and therefore the Q of the system, our focus, right, is going to be positive or greater than 0. However, if energy is leaving the system and going to the surroundings, then the system is losing heat. And therefore, Q, again, the amount of energy the system has, is going to be negative because the heat is leaving the system. And Q will be negative. All right, so there are a couple vocab words that describe this process, and that is endothermic and exothermic processes. These describe those two situations that we just covered on the last slide. In an endothermic process, energy is transferred as heat from the surroundings to the system. In other words, heat is moving from the surroundings into the system. The system is gaining heat. This is known as an endothermic process. In this scenario, the system's energy is increasing while the energy of the surroundings is going to be decreasing. The opposite of endothermic is going to be known as exothermic processes. And in this scenario, energy is being transferred again as heat from the system to the surroundings. This is that second example on the previous slide. Energy is leaving the system and going to the surroundings. This means that the energy of the system is decreasing while the energy of the surroundings is increasing. So if we look at these two examples, right, in terms of the ice cubes melting, the ice cubes are absorbing energy from the Bunsen burner. So the ice cubes are our system. So energy is being absorbed into the system from the surroundings. This is an endothermic process then. Whereas in this container, as you can see, heat is being given off. You can kind of see the flames in the beaker and the smoke, and heat is being given off in this system, whatever it is. It's a reaction of some sort, giving off a lot of energy. That's energy leaving the system, the inside of the beaker, and going out to the surroundings. This is a loss of energy for the system, and therefore this is an exothermic process. All right. So if you have any questions at all, as always, please let me know, and we'll continue talking about this in the next lecture video.